Thanks.
You're welcome.
That goes to that. Oh, you did? Never seen it. Normally goes to that black screen meter.
When I present a certain way, a certain way, that Teams action.
Yeah.
Oh.
Okay.
All right, we're going to get started with our next presentation. So we have Deeper from SLR Consulting. He is the senior principal out of Houston. He's an experienced professional engineer with extensive history in the environmental service industry, strong leadership, mentoring, and technical skills with a broad industry and agency relationships, and experience providing value to clients. Highly skilled in air permitting, compliance and pollution control, climate change, environmental and management systems auditing, technical litigation support, EHS consulting, and project and program management and delivery. He has a bachelor's of science in chemical engineering from Cornell University and a registered PE in Texas.
All right, thanks, Tanya. I think that's my LinkedIn profile that I updated about maybe 54 weeks ago when I was looking for a new job. I'm no longer looking for a new job. Those three initials that you see up there are correct. Two of them are different than most people are used to, but they're definitely correct. So the last time I spoke at a conference was in this room in February of last year to a pretty packed conference. I think it's fitting that I'm back in the same room speaking for the first time since then. So used to looking at a monitor and not real people. So the genesis of this presentation really came about a year ago or so. AFPM had a series of webinars instead of their face-to-face environmental conference last year. And I was part of a panel, and we talked about, the upcoming transition that hopefully the refineries are going to be able to make to go from Method 21 to the OGI camera. And at the time, this was first week in November, last week in October, EPA, Karen Marsh out of OAQPS, who's usually a speaker at this conference. She couldn't be here because she's too busy working on rules. She spoke and talked about how EPA was going to be working on updating the alternate work practice and the Appendix K protocol. We'll have them both coming out. They'll be in 2021, and then we'll have some better guidelines, hopefully, for folks to use OGI, and it would get rid of the annual Method 21 requirement that we'll talk about. And we thought, hey, this is great. So 2021, we got some things to look forward to. We were thinking last October, November, we thought, well, we'll be COVID free. We'll have the new AWP and Appendix K, and then we have billionaires achieving space travel. So I guess we're only 1 out of 3. So I'm going to talk about this transition and some of the plans that I think EPA is considering. They're pretty tight-lipped right now. And I would also refer folks, if they're interested, if you get any back issues of Fugitive Emissions Journal sitting on your bedside table that you haven't gotten to, the April 2021 issue has a lot of this information in it. Oh, it's not there. Oh, all right. This is very confusing. All right. So I am going to talk about summary and a background of the AWP. I'm going to talk about some lessons learned in the upstream, stream, and downstream industry. I'm going to talk about some OGI considerations that I'm sure EPA is considering for this rule. There's a full abstract. I think the picture on the right, I grabbed it from EPA. Is that your grandfather, Terrence? I'm thinking maybe that was, yeah. All right, let's talk about a summary of the AWP requirement. So the alternate work practice came out in December of 2008. You know, its goal is to achieve the same level of emissions reduction current Method 21 LDAR work practice. It's not there to find the same leaks. It can't. But the premise was you monitor more frequently. If instead of quarterly, you do every other month. So every 60 days or so, you're looking for leaks. You find the bigger leaks, and then that's equivalent to going out and doing your quarterly monitoring. Of course, OGI doesn't discriminate about what it's looking for, so it sees all kinds of leaks, as you've heard in previous presentations here. You have to submit that data to EPA, and then the only stickler, this last bullet, and that's really what has tripped everybody up to this time, of course, is that the emissions equivalence, in order to demonstrate emissions, you had to do one of those 6 events a year, had to be Method 21. And from a cost perspective, it really just doesn't work out. You'd have to have, tagged components, and you'd have to have, all that work done on an annual basis. I think a few pilots were run around that time period, a dozen years ago. So people looked hard at it, and even though some consent, a lot of refining consent decrees at the time, was really before any, they all had a section that talked about how you could use optical gas imaging. I think nobody wanted to be the first. Right? Nobody wanted to take the leap. And there might have been some other issues with your state or not attainment rules and requirements. But basically, that's what held everybody back. So really, there's been in really a pretty slow adoption here in the U.S. Canada, they had a smell out a few years ago, and like the midstream and upstream rules in Quado and the way it came out, they were tailor-made for using optical gas imaging. So the rules were set up that way. Refineries go back to triple G, triple GA, VVA. They're really just not set up for it. So really, that was why OGI is seen and used more for safety and maintenance applications. Right? There's rarely a facility I go to, whether it's refining or a gas plant, that doesn't have a camera. But really, it's used for a lot of non-regulatory purposes. It's used more for those applications, again, because of the cost neutral at best aspect. You might have some state rules or equivalencies. For example, they're holding back. For example, in Texas, it took about a year and a half after the AWP came out, the TCQ in their rules, so people could use it. But again, if you have a permit, you might not be able to use OGI. And really, there's no leak quantification standard for annual emissions reporting. So I know here in Texas, they really want to take actual readings, right? What do you use if you've got cloud or no cloud, right? Unless you're going out and you're measuring it, and that's even more, more resources, more cost, and again, who wants to necessarily be the first one? You see a lot of the current application of OGI for LDAR has been, diagnosing maybe big leaks, maybe line monitoring, exceedance. We're getting high benzene. Where is it coming from? Let's use it in the field. Has been used under some AMLs here in Texas. That's an alternate means of emission limitation. The TCQ has approved a few facilities to use it for difficult to monitor components. And really, that was a pretty easy sell on the agency's part. The I've seen don't really have a whole technical base to say, no, this is already approved as a alternate work practice. We should use it for difficult to monitor components. And by the way, it's safer, it's more efficient. We want to do it, and I think they actually even do it. They might do it quarterly because they can just do it frequently and easier. I've seen some unsafe to monitor plans at facilities. They go ahead and use it, right? Because you're supposed to monitor it at safe to monitor times, which is typically when there's no hydrocarbon in the pipes, right? Which is never exactly. Thanks, Mike. Never happens. So why not take out the camera and just put that in as you plan? Again, not written into the rules, so voluntarily done. And I've seen it for other things like our control devices working properly or not. Whether they're sewer controls, maybe look at your flare or something like that, and vapor control devices and stuff. So it's been adopted, and an API really out to change that. Starting in 2019, that group has really engaged EPA. They've been advocating to develop a revised alternative work practice. They want to bring, OGI really back. The technology is kind of ahead. The rules really aren't there. They need the rules to adjust, right? This is sort of a, tortoise and hare, right? The technology is so far out in front, but the rule is not there for people to do it, and that's what they're advocating for. And I know they've been working on it so that this process really right after the AFPM environmental conference last year. Actually, on my first day with SLR, I had to do some safety training, but then I had to jump on spend as much time as I could over those 2 days because EPA had this stakeholder workshop, and I know a lot of folks in this room who have just presented, spoke at that, and really that was for EPA to collect data, right? So they were bringing in, FLIR and Montrose and others talk about their experiences. It was really sort of just a, OGI-a-palooza, 2 days worth, right? To get all this information out there. So EPA could listen and take notes and try to understand, where the technology is, what people have learned from, everything from the, the MUTEC study to other data people have submitted. So they could work on this Appendix K and put the right things in for the monitoring methodology. As you can see there, they said we're going to develop this new AWP for refineries. We've got a draft targeted for, let's just call it 2021. It didn't really work out like they thought, and they also said that why did they not? Why is mid to late-ish 2021 and there's nothing? Well, it's because this executive order came along on the first day of the Biden administration. The executive order on protecting public health and the environment and restoring science to tackle the climate crisis. And specifically, it says that EPA immediate review of agency actions in January 20th, 2017 and January 20th, 2021, reducing methane emissions in the oil and gas sector. And they'll do this by September 21st of 2021. So they're about a month on their deadline. That's why every time I call Karen, she's a little impatient with me, or when Karen calls her, because she's got to work on this. She's got to work on the rule, and she's got to move this around, and they got to repetition, and it's 3 parts. They haven't had as much time to do it. They're probably always too ambitious with their goal. So that's been a priority. There have been some other AMLs that are in the agency. If you talk to any of the Molex guys, I can't ever remember. Impact 2, is that what the company is? I have a hard time remembering what that is. They've got an AML submitted for this network, this sensor network, which is supposed to pick up concentrations within the unit, and then if it trips above a certain level, then you send someone out. So it's really more of more passive monitoring. They have been looking at that, but they really haven't focused on too many other things. I think that's been pushed, but EPA is sort of throwing everything else to the wayside as they respond to this executive order. So I had hoped, again, back to last fall, that maybe if there's a conference sort of in the summer of 2021, this will be out. This will be a great topic, right? We can have a big discussion, bring up a panel and stuff. Instead, I wrote an article in the spring for FEJ. It's called "Coming Soon." It was more of a question mark on the protocol, and maybe it's not going to happen as quickly. So really, what I'm going to talk about next is some of the lessons learned to give you an idea of some of the things that EPA is talking about. So, from using OGI in a few places, there were some, at one point there were 9 or a dozen midstream companies, I think using it as the AWP. Well, what have we learned about it? And some of this also from use in Canada. Well, it consistently can find, over 10,000 parts per million, right? You get some lower concentrations, just not as reliable lower concentrations. And again, you monitor more frequently because the high concentrations really, constitute, 80, 90% of the emissions. And this is all about reducing emissions. Definitely more productive. It depends on how you're sort of staffing the team. If you got a 2-person team, which is more conducive for safety, and then sort of trading off those responsibilities, it's not going to be as fast. It's probably more productive, and that's really what you want is quality monitoring, not just faster monitoring. So you can go several times faster. I think you've got data that 20 times. I don't know. I would say it's single-digit number is probably more realistic. It just depends on the density of components and all sorts of things. And it picks up all sorts of non-traditional equipment, of course. Ambient can affect the detectability. So those things need to be taken into consideration. It's certainly a safer monitoring technique for Method 21, but it's not without its own challenges, right? You're out there carrying a camera, right? So you have sort of, fatigue. You can get eye strain, right? If you're just looking into the camera, you get tunnel vision, and you've got different safety issues also because you have slips and trips and falls, and you can't always see everything that's in the camera. So all of a sudden, pipes not in the camera are probably closer than they appear, right? So you get bonked on yeah, exactly. Dreaming in black and white infrared, you get it toggled and stuff there, and you can't look at anything normally anymore. So things like using the flip out screen, using a shoulder harness, using a monopod, trading out with 2 experienced people, maybe one or maybe both capable of making repairs. I mean, those are some things that have worked well. It's still time consuming, with these videos, doing the transfers and stuff. And really, do you have to take a continuous reading of everything, or are you just recording the leaks? I was in this room, a year and a half ago, and we were talking about still OGI and going back to the future with MPLX, because they started at OGI on their midstream plants, got a consent decree, and then went back to Method 21. One of the reasons that Don Kinder gave, standing up here to the room, was that he had a West Virginia inspector who said, prove to me that you monitored this pump on this day. Right. That was that was the level of skepticism at the state level, and they also didn't want to be first, to come under a consent decree, and then how do you do comparative monitoring, right? So there are questions in their mind. So the record keeping, can be can be certainly a challenge still, and that's not fully answered yet. All right, so that was sort of midstream and refining. What is upstream learned? Well, the METEC study, and I know we were covering that as I came in. So this OGI Institute at Colorado State University during 2020, they have this methane emissions evaluation center. You can see this picture of the fields where they had some simulations of pipeline right away of different and whatnot. You know, and like and they invited different contractors and companies to come. Bring your own protocol, bring your own camera. You know, we're going to have some stuff leak. So there's maybe a little bit of bias knowing that they're looking for leaks, but they brought sort of experienced crews and lesser experienced crews and did a series of tests. It's like the Hunger Games of OGI, right? Except nobody perished. So and they got a bunch of data and got a whole bunch of lessons learned out, and even developed, I think, their own training program out of it based on what they learned from this. And basically the goals of this study were to provide basis to compare the next generation solutions to OGI surveys. They wanted to better understand the efficacy of OGI surveys and really get guidance and information for improving leak detection performance using OGI. So again, these are blind surveys, and they had a whole bunch of findings, but the two that really stood out to me were, and they emphasized this first one many times in many different ways, which was experience counts. And by experience, they mean knowing when to slow down and just being better at finding leaks just based on experience, right? You know where to look, you know where not to look, you know where to get that optimal delta T. Those thermographers that had more experience, more time in the field, outperformed those with less experience, right? So that's an important takeaway. That's probably something EPA is thinking a lot about. Another thing that I thought was interesting was for those more experienced thermographers, wind speed wasn't as much of a factor. And I know I've been at other presentations where, especially up in the Mountain West and some of those states up there, I've seen companies talk about guidelines for we don't monitor above this wind speed because just we're not going to get much. And I remember Don Kinder telling a story about during his training, his OGI training, he was looking for a several thousand ppm leak, and maybe it was an 8,000 or 10,000 ppm leak, and he had to be like 6 inches away in order to see it. It was an extremely windy day. So I think it still is a factor, but it seems like from this study at least, it's all in the training really. So that brings us to some of the results and some of the issues and considerations, and these are really the things to think about as EPA is coming up with Appendix K and figuring out how to revise the AWP. So we know that AWP catches the big leakers, right? And that gets the emission reduction. But you can't really compare leak rates between the two. So that's a challenge for comparative monitoring. And without, like, connectors are obviously, I'm speaking from the refining standpoint. Refining, connectors are not part of the regulation, right? They don't have to monitor connectors unless you've got a more stringent state permit in effect. So they haven't been monitoring connectors. Well, you go out there and you start doing OGI, you're going to find some connector leaks. You're going to fix them, but connectors are non-actuated equipment. So you're not going to get a whole lot of repeat leakers from them, right? You fix a connector once, It might not even leak again as long as you're at the facility. So unlike valves and pumps, which leak, even after you fix them, connectors don't. And so that equivalency argument is tough to make. And that's really what API has been fighting on the numbers. From EPA's perspective, so that's sort of the challenge in getting the equivalency. From EPA's perspective, and others, thinking about how to do OGI better. I think these three issues that I've identified, these questions are ones that I think EPA is considering, right? I don't know, because I don't have a window in what they're doing, but I think these are three important questions about, OGI surveys. Are they too fast, right? That's what got Method 21 based programs in all kinds of trouble near the beginning of my career, which is why I'm standing up here, because I just had some good timing and got sent to a refinery in 1997 that was undergoing one of these, they would have gotten the first consent decree, but they were 4 years early. So on LDAR enforcement. Second issue, what sort of training, oversight, QAQC, what sort of guidelines should be in place? Really, that's what Appendix K is. It's going to be a monitoring protocol, so you can get repeatability and you can get uniformity and consistency among technicians, right? And gosh, we hope they write it better and more clearly than Method 21, right? Which is sort of evolved in interpretation over the years. And then finally, how do you demonstrate compliance, right? Video record keeping. How best do you demonstrate that someone is actually out there putting on it for the appropriate amount of time? So I'm going to talk about each of those three questions. So first consideration, should there be a minimum scan time for OGI monitoring? And I know two presentations before this, they talked about how there is a, TCQ got an air permit back in 2018, I think it was, where they've got the first OGI based condition written into it. I think that was a 3-second minimum time per component or for every component within the view. I'm not sure exactly how they document that they do that, but I think that's definitely a record keeping challenge. But when you think about a minimum scan time, I sort of think about detectability versus productivity. So I've got this chart up here for everyone to see. This was something that the folks at Sage came up with years ago, and what you've got, yes. Laser, excellent. So they have a comparative monitoring score. This was their own device, naturally on a scale of 1 to 7, and they had average daily productivity. This is Method 21 monitoring. So 239 events per day was the average, and they drew a vertical line here, and then they took a horizontal line here at 3.5, which is the midpoint of their scale. Again, quality versus productivity. But I think a way to think of this is in terms of the quality, I think, is a proxy for detectability, right? Because what you want to be able to do is detect stuff, right? I mean, you can go out there and have all the productivity you want, but if you're not finding things, that's no good. So what they did is they took this data and they plotted all the third-party comparative monitoring audits they had done. Then they talked about the different zones, right? So this zone over here is the worst possible, right? Because it's poor quality and it's low productivity. Right? So it's costing you a lot of money and you're not finding leaks, right? As opposed to this one over here, this is the ideal one, right? This is efficient. You're very efficient, very productive, and high quality, right? Well, it's hard to get there. Down here is it's low quality, high productivity. You don't really want to be there. This is okay. This is kind of the second most desirable quadrant to be in, right? This is good consequences, meaning high quality, right? And then as you get toward the center here, you get better productivity. So really, when you're out there monitoring, you want to make sure, I think, whether it's method 21 or in this case OGI, you want quality monitoring because you want to find leaks, right? So that's how I think about that. So, which raises the question: should there be a minimum time? Is 3 seconds enough? Is 3 seconds for everything on screen really enough? Because there's got to be an upper limit in my mind. Now, I don't know if EPA is going to come out and how they're thinking about where they're going to end up rather on this question. But in my mind, as someone who audits these programs and looks at reams of monitoring data, you definitely see people getting in trouble when they go too fast, and I think that can happen with OGI. We've looked at some videos from sites, and sometimes you can't even follow them, right? I mean, I know if you're not the first person, it's like watching a GoPro video from the X Games or something. Like, how can you see what's going on, right? And then it's going black and white and it's flipping, right? So are you really spending enough time, right? So there's got to be a balance for productivity and detectability. Yeah.
Comment about that may actually go in distance from the actual. Closer you are.
Yeah.
To that alone, that amount of time spent scanning that may not be too much. You're
Sure.
kind of looking at DTMs in a bike rack. You need to slow it down.
Right.
So you're catching all those components.
Absolutely. Yeah. Yeah. I mean, it's another form of AVO, right? And we know how fast AVOs go, right? I mean, sometimes you can practically jog through the unit, right? And do a bunch of AVOs. But again, the mission is to find leaks. And, 20 years ago, Ken Gehring would stand up in a room like this and talk about, or Joe Wilwarding, and say, why is there an issue? It's because you're monitoring and we're looking for leaks, right? You're just going through doing the monitoring. So I think people need to keep that in mind, right? And like you said, Mike, that last bullet, requirements for maximum viewing distance or additional viewing angles to avoid missing leaks. Right now, there's nothing in there. Should there be, right? Should you be monitoring on the front side and the back side just to give yourself an additional view, right? I think those are considerations. All right, next round of considerations. What about guidelines? And that's sort of a broad category. There's a lot of different guidelines, and I've put a few of them up here. Certainly the ambient conditions, right? Other upper limits on wind speed, to be able to detect a leak. I've got it's not listed in the bullets, but I've got here a Providence Photonics chart that I found online researching for this. And, they've got some minimum distances and delta T's, where they're not really able to find leaks, So this is, how do you put this into a procedure in the field, right? How do you adapt? How do you write guidelines, in order to give your camera, the best capability to find leaks under different conditions? Is there a QA/QC aspect? Like the timestamps that we see, right? And Robert, you guys have this great program that I love because it takes everybody's data, looks at the start and end times, looks for pace anomalies and stuff. I mean, is there a way to have a governor on the camera, or to go back and get some timestamps on stuff to look and see how fast people are actually doing it? I think a big issue, and one that was talked about, a fair amount at that EPA meeting, was certification, right? And this goes back to, the CSU METEC study, right? I mean, that is their conclusion, I think, is training and probably certification is something that should be looked at. I mean, more experience gets the job done better and gets good quality. And when you start dropping on quality, that's where you could go through this whole consent decree cycle all over again, right? I think what everybody would agree is that we don't want to get into the same point where we're all so comfortable with the technology that we don't see some of these things and we allow it to get, you know, monitoring to get too fast and that quality gets lost. And then the enforcement, you know, cycle repeats itself. I hope to be retired by that time, by the way. So you know, so anyway, training, you know, field apprenticeship, plus classroom training, all that stuff. How many hours do you really need to get somebody qualified to find those leaks? The third consideration I have for OGI AWP, and this is Rex Moses's slide. He's talked about this in the past about, you know, optimal routing and stuff. You know, how do you demonstrate compliance through record keeping, right? Should you have, you know, video recordings for all components, right? Then like here, I mean, how do you transfer it? How do you store it, right? They're recording this right now. They came in right before I got up here, stopped the video from before so the file didn't get too large. And then you've got 45 minutes of me droning on, and that's going to be its own large file. You know, and this is just a conference with, you know, 80 presentations today or something like that, let alone, you know, thousands of components and hours of monitoring. So what about GPS tracking? You know, tracking where the technicians are. Certainly monitoring pathways, viewing locations for camera surveys, right? I mean, I wonder if we're gonna have sort of, you know, scenic viewing areas, right? Assigned scenic OGI viewing area up ahead on the left or something. We'll have a series of dots all over the refinery. Some elevated, some at ground level, you know, in order to make sure the technicians were there. Maybe there's timestamps on the GPS, right? As an auditor, I always think about auditability of this stuff. So I think those are important considerations. And some of them, you know, are maybe your technology issues that, you know, Craig and others are solving, and some of them maybe are just, you got to write a plan. You're going to have to live within these guidelines. I think those things are all going to be on EPA's mind, because again, uniformity, consistency, repeatability. Those are the hallmarks of a good leak detection and repair program. Maybe even some, I don't have it up here, but another thought is, you know, random that I know some people do, random surveys, you know, outside of the 60-day monitoring surveys, right? Some independence, bring somebody out from another site, you know. What's that? Like a comparative monitoring? Yep, absolutely. I mean, I go audit plenty of sites these days under consent decree, and, you know, they have somebody coming in each quarter and picking part of a technician's route and doing it just for good QA/QC purposes.
So for reviewability, that's really what it's kind of boiled down to. If you don't have tags in a database, it historically look back in history.
Yeah.
Show you that you monitor this valve on this day or this, you know, pathway. Photographer, they one thought, plant some barcode tags.
Right.
Develop a path, and then they have to get those, scan those barcodes in order. So it's
Yeah.
the same. You don't have a technician coming out following them.
Yeah, they may have to, you know, badge into, you know, area 3 or something like that. You know, there may be some of that. Because I mean, anybody in this room who has, like me, who has kids, although mine are essentially full grown in college, you know, they will find a way around the system, right? So I mean, you gotta design the system. So yeah.
But wouldn't the fact that they're recording the entire time alleviate a lot of these problems? I mean, the entire thing's being recorded.
Yeah, no, I think so, but at some point you've got, I guess the thought that comes up would be, you know, afterwards. Yeah, you might not be able to tell in the recording, and it's also sort of like saying, Well, find the recording from 4C where that person coughed in the background. How are you going to do that, right? You got to go through umpteen hours of reviewing video and stuff to find it. So
Just, we've been through audits before that have issue locating it, but if you break it up by, we found it's breaking it up by skid
yeah,
and labeling it as such.
Yeah.
So then you're able to quickly go in.
was that in sort of an upstream application or?
It was processing
Okay,
actual state audit. Had an issue.
gotcha. Okay,
Consideration, not the recorders.
right.
These have auditing capabilities.
Right.
It's required.
It is now.
It is, yeah.
That's one of the considerations.
Right. So the consideration, could be to not have to record. I mean, I think that's the preference, right? So it's sort of how you get over that, how you get over that hump, how you get over that, that trust. And to me, it's sort of a, is it practically auditable, right? I mean, everything's within walking distance if you have the time, right?
And I understand what you're saying. It's the ability to audit as such. Not just looking at numbers.
Right.
Spreadsheet.
Well, I haven't figured out how to do it yet. Maybe because I haven't had to figure out how to do it yet, but I'm just trying to think ahead. I see how this technology is going, and I think it's headed in a good way. I just, there's some of these considerations that they've got to figure out. So really, in closing, just this is sort of a roll up of the things we've just been talking about. So just some of these issues and considerations, I think, for a successful revised AWP, training, verification of camera capabilities, survey procedures, appropriate record keeping, all of that emissions equivalence. They've still got to work that out. Derek Reese of Exxon and the others at API leading the charge, I think, are still trying to wrap their heads around that. There's two questions that I always sort of have about this, and I've mentioned them, I think, a little bit at the start, which is, are your state air permits going to allow you to do this, right? So what sort of steps you need to take to unwind stuff within those permits? And as soon as EPA comes out with its Appendix K in draft form, I think that's something to start thinking about, because that's going to take time. So I think sure everybody's going to want to go, and I'm sure people are starting to think about pilots and how this might work. But you might have to get some of the regulatory red tape fixed first, and then if you got a straight OGI based program, you got to work out emissions and stuff, and how is stuff going to be permitted, how is stuff going to be reported. So those are still a couple of open-ended questions in my mind. And I think I am right at my time, so I've one more minute while we look at this pretty picture that I took from Greg's website. I gave him credits.
Does anyone have any questions?
Not everybody at once. Right.
Great, thank you.
Thank you.
Well, this was a great presentation for prefacing our next presentation, so stick around, we're going to be starting our next one quite soon.
I meant to point you out when I put you back up. I forgot.
I get started.